So the things that you need to know, show things on, the things you need to know for the quiz on Friday are phosphate, carbonate, acetate, hydrogen carbonate, ammonium, sulfite, cyanide, hydroxide, sulfate. All of these are on your polyatomic ion sheet. And you can memorize them for quiz on Friday. All of the following things, names, formulas, as well as the charges.
Isn't the charge uniform?
Yes. Okay, so let's go into details about how we name compounds. We've already been naming compounds. First thing you need to do is determine if the compound has a polyatomic ion. So polyatomic ions are all the ones that we already talked about in the previous slide. So those are things you need to memorize. So the first thing, after you decide whether it has a polyatomic ion or not, second thing that you're going to do is you're going to name the cations first. And then the anions. So tell me, cation has a positive or negative charge? Positive charge. And you know that because it's got that C that looks like a plus? Okay, how about the anion? Does it have negative or positive? It needs to obviously have a negative charge. If the anion is coming from the periodic table, as in it's not a polyatomic ion, it's not on that chart, right? If it's ending in IDE, it's coming from the periodic table. So chloride will be coming from periodic table or polyatomic chart. Periodic table. Based on that, you'll know what the charges are, because if you look at the periodic table, it looks something like this. Remember, here's helium up here, and your, let's say, hydrogen down here. All of these guys has charge of 0 because they're noble gases. Then the next column has charge of what? Negative 1. That means every single element, fluorine, chlorine, bromine, iodine, they all have charge of negative 1 when they become an ion. You know that something is an ion if it ends in IDE. So chloride should have what kind of charge? Good. How about nitride? Negative 3, because oxygen's column is going to be negative 2. Take out your periodic table, please. Okay, so let's go through it. I want to make sure you understand what I'm saying. I want you to take a pen or a pencil, and I want you to write an arrow that goes on the column 18. Do you see where it says group at the top? So we count, eyes up here please, because you're going to miss this if you don't watch me. Okay, group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, what do we call the elements that are in between group 3 to 12? Good. They do not get a charge. We need to assign their charge, right? Because they have more than one charge. Now, group 1, I want you to draw an arrow on top of it and write, these are going to be positive 1 when they have a charge, always. So lithium, when it becomes an ion, it gains a charge of what? Positive 1. Good. Beryllium, which is group 2, has charge of? Positive 2. How about group 13? Do you see how we skipped over transition metals? Good. Boron will have positive 3 charge. So aluminum, gallium, indium, thallium, when they become an ion, will have positive 3 charge. Now, carbon's column 14. They're a little finicky. So we're going to say either positive 4 or negative 4. Now, nitrogen, however, group 15, what kind of charge will they have? Negative what? 3. How about oxygen's column? Negative 2. How about fluorine's column? Okay, now watch this. Only the columns that have negative charges when it becomes an ion will have IDE ending, not the positive columns. So, when phosphorus becomes an ion, what would it be called? Phosphide. How about sulfur? Sulfide. How about bromine? Bromide. Good. Question. However, if you have a polyatomic ion, Polyatomic ion is kind of like buying a, you know those Lunchables that's already been prepackaged? Those sandwiches that's already been made? That's what it's like. Polyatomic ions are already packaged. It's saying you don't have to do any work. I'm telling you that when you have PO3, it's going to have negative what charge? 3. So polyatomic ions are already prepackaged. So we don't have to look at the periodic table. All we have to do is look at that ion, sulfate, SO4. When you have SO4, you're always going to have negative 2 charge. Does that make sense? Okay, so understand the difference between ions that you get from the periodic table. You only know that because it ends in IDE. Otherwise, see if it's a polyatomic ion, and if it's polyatomic ion, you can get the charges and the formulas from the polyatomic chart.
Will that go first, or does cation go first?
Okay, anions always go last. Polyatomic ions, if they're negatively charged, will they go last or first? Last. Same rule follows. Polyatomic ion, if they're negatively charged, are still anion. So they go second. Okay, so what was the role of Roman numeral? Okay, Roman numerals are used for transition metals. Can you tell me the group number for transition metals?
3.
Groups 3 to 12. Okay, used for transition metals. What about transition metals are these for? The charges, right? Just like Inza said, I'm talking about the transition metals charges when I'm talking about Roman numeral. It shows you what the charges are. Okay. When you name certain metals, you're going to need to include the Roman numeral. What type of metals are we talking? Transition metals. Which metals do not need a Roman numeral? Everything but transition metals. Everything else. I'd rather you be more specific. Oh, well then I would say, remember, transition metal we said belongs to group 3 to 12, right? So remember, here's a periodic table. Everything behind this is called what type? Metal or non-metal? Non-metal, right? So, if these guys up here, the triangle, are non-metals, these guys, they're actually these guys, the light blue ones, they're tricky, okay? So I'm going to show you how to do that later. But these guys, are they metal or non-metal? Metal. Are they transition metals? No. So therefore, you will need not to use transition metals. So for group 1 and 2, these guys are the ones you do not need to write the Roman numeral for. Imani, wake up.
So you're saying that group 13, 14,
those are iffy because lead sometimes yeah. Gases you're not going to need to write that, right?
So we don't.
You don't write Roman numeral. Oh, there it is. Okay, so if you want to actually write down the answer that goes with the slide, here it is. So, exceptions, do you guys see the exceptions at the bottom? To the ones that do not need a Roman numeral, that's Al3+, zinc 2+, and Ag+. Assume that everything else needs a Roman numeral. Okay, going over this, I have sodium oxide again. You don't need to worry about switching any of the charges because the formula is already written. The only time you have to worry about, do I have to bring down the charge crisscross method is when you're writing the formula. Here we're naming the compound. So sodium, is it a transition metal?
No.
It's not a transition metal. That means do I need or not need a Roman numeral? I don't need a Roman numeral. So go ahead. Let's go to the next one. I have, first of all, that's nitrogen, right? Is it a polyatomic ion?
No.
It's not. If it's not a polyatomic ion, nitrogen comes from what? Periodic table, what I'm going to name it by? IDE. So I have lithium
Nitride.
nitride. Okay. This one, ClO3. Do I have a polyatomic ion?
Yeah.
Yes. So what is that called?
Chlorate.
Chlorate. What is the first one?
Silver.
So I have silver.
But don't we need a number for that?
Okay. Silver. Was it on the list of things that need or need not a Roman numeral? Need not Roman numeral. Look at your slide. Okay. Next one. Do I have a polyatomic ion? Al2O3. No. So oxygen is going to be instead called oxide. What is Al? So I have aluminum oxide. Next one. Do I have a polyatomic ion? What is it?
Carbonate.
Carbonate. What is the first one?
Calcium.
Calcium. So simply I have calcium
Good
carbonate. Okay, go ahead and finish up the practice 6 through 9. For those people who are done, go ahead and make sure you have. Okay, this top number, that number, this number, this number, this number, those are your charges. Bottom number, this number, this number, this number, that tells you how many of the elements that is in front of the number you have. So here you have CO3. Together they have 2 minus charge. Do you understand? Okay, understand what the charges and the subscripts mean. Because some people on the homework, they wrote the number of the atoms up here. That's incorrect. Okay? Alright, so go ahead and do the rest of them and we'll go over it. Yes, ma'am. Okay, in class practice, BaCl2, I have magnesium hydroxide, ammonium oxide, potassium, hey, I can't hear her. Please be quiet. So, listen first and then ask questions. This one says FeO. Alright, I don't know what the charge of Fe is, but I know that that's a transition metal, right? So I need to figure out what this guy's charge is by figuring out what that guy's charge is. Oxide has a -2 charge. I know that from periodic table. When you add the negative charge, total negative charge to total positive charge, they have to add up to 0. So that means if I have oxide that's -2 charge, iron has to be +2. So that means the charge of iron here is going to be 2. When I write the formula, I have iron 2 oxide. Okay. Yes, write the parentheses. Now, I want to do this one, Cr2O3. Oxide charge is always going to be -2. I know that because it comes from the periodic table. However, how many oxygens do I have?
3.
3. So if I have -2, I have 3 of those. So total negative charge I have is -6. So chromium, when you have 2 of them, I have to have +6 charge, right? So if chromium times 2 has to equal to +6, because when you add +6 to -6, they have to equal to 0. What is the charge of chromium? 3. So, chromium oxide here needs to be chromium 3 oxide. Okay, now I have time for this. Do I have a polyatomic ion?
Yes.
What is the charge of this guy?
Negative.
-1. How many of them are there?
2.
So I have -2 charge. Cobalt so has to give me what charge?
Negative. Has to be +2.
+2, right? Because this guy plus whatever total negative charge I have has to equal to 0. So this guy needs to give me total +2 charge because these guys are giving me -2 charge, which equals to 0. When I write the formula, I have cobalt, parentheses, 2, nitrate. Okay, I have time for CuCl2. All of this is for homework. Do it, bring it tomorrow. I'm going to check it on Thursday, but I try to work it out. Chloride has what charge? Chloride has what charge? Positive one or negative one? Negative one. I have how many of those?
2.
So Cu has to be what?
2.
+2, right? So I write copper, open parentheses, 2, chlorine or chloride?
Chloride.
Chloride. Good. This is on the video, so watch it at home and wrap up. Hold on. I've got to pause this.